All right, so here's a solution to the first practice problem. So we got a cart on a ramp, and we'll draw some wheels on there, and we want to know what its acceleration is. So we're going to use forces to solve for acceleration. The sum of the forces equals mass times the acceleration. And we need to solve this left side here, what forces. So to do that, we have to know what forces there are. So we think about it, and we know that the cart is touching the ramp, so we have a normal force perpendicular to the ramp, and the cart's on or near a planet, so we have gravity pointing towards the sun of the planet or straight down. The cart's going to accelerate down the ramp in that direction. Now, the acceleration doesn't line up in the x and the y, so it would either show up in both, or what we're going to do here is we're going to rotate this thing around, and when we do that, it's going to look like this. And now the acceleration is all in the x direction. It makes it a whole lot easier to solve this problem. So we look at the forces. Normal's not in the x, but gravity is, but it's not all in the x, so we have to do g cosine theta equals ma. So that brings us to the question of what angle is theta? Well, if we look over at our ramp there, I always go back and reflect at this. It's 4 degrees for the incline of the ramp down here, and we know that it's a right angle of 90, so that means that that angle between the gravitational force, which points down, and the ramp is that 86 degrees. So the gravitational force is little m little g, mass times gravity. And that gives me mass times gravity cosine 86 equals mass times acceleration. Now notice the mass of the cart wasn't given, but that's not a problem because it's on both sides of the equation and cancels out. So we know that 9.8 is the acceleration due to gravity on Earth, and my calculator tells me that cosine 86 is 0.070. So I multiply all that together and I find out that the acceleration of this cart would be 0.68 meters per second squared. The problem also asks how much time does it take, and if I'm looking for the time, I'm going to use kinematics. My initial velocity is 0. The acceleration is 0.68 that we just found, and delta x is 2 meters from what the problem tells us. And we're looking for what the time is. So I use my kinematic equation, delta x is v0t plus 1/2 at squared, and I bring in the pieces that I have. So delta x is 2 meters, and the initial velocity is 0, so that whole term goes away. And my acceleration is 0.68 and time squared. So now I can go through the algebra, divide both sides by 0.34, and then I have to do the square root to undo t squared to find out what t is, and I find out that t equals 2.4 seconds.